All right, welcome back, Hononegah Honors, Algebra 2. Section 5.3, Day 2. Today we're going to talk about something that we've actually done a couple of times this year already. We're going to talk about transformations. So when you're talking about graphing and you want to shift something, or you want to translate something, or you want to do a reflection, or a vertical stretch, or vertical shrink, and things. So these are things that we've actually already talked about a little bit today. So let's talk about each one of these one more time because there still are some individuals that struggle on this. So if you are going to do a horizontal translation, or basically shifting the graph left and right, now you're talking about replacing x. So I'm just going to put rx. So replacing x, and if you're going to the right, you are replacing with x um, minus the number, and if you are going to the left, you're replacing it with x plus the number that you're going. Now, a vertical translation, you are merely just adding or subtracting the number to the entire function. So again, if you want to translate something up, you would add a number. If you want to translate something down, you would subtract a number. So that's probably the easiest one of all of these. Now, reflection, which basically flips the graph over the x-axis. So this one's a little weird because they got both of them in the same one. If you're going to do it over the x-axis, and I'm going to put it right here, the x-axis, you're going to multiply everything in the function by -1. So that's for the x-axis. And the y-axis, you're going to replace x. Okay, so again, replacing x versus doing it to the entire function. A lot of you messed up that multiplying everything in the function by a negative. Horizontal stretches and shrinks, you're going to replace x again, but you're always going to replace x with the reciprocal. So if you want a shrink of 3, I'm going to go all the way to the other side here. If you want a shrink of a third, then you're going to replace x with 3x. So again, it's the reciprocal up, but you're going to replace x. And then a vertical stretch, you're going to times by whatever number you want to stretch it or shrink it. So you're going to multiply the whole function by that number. So again, we've done this before, but some of you still struggled on it. I want to describe what happened. So they went from x to x plus 2. Well, that is a translation to the left, 2. And then they put a -3 at the end. So again, that is a translation. Now, whether you write it twice or not, down 3. So let's graph the original function. The f of x equals square root of x. So 0, 0, 1, 1, 4, 2, 9, 3. And I also don't want to write those out. So 1, 1, 0, 0, 4, 2, 9, 3. Those were all points that I graphed for the first one. Now, you can do this one of two ways. You can completely and separately do the other one. So again, like we did yesterday when we did graphing square root functions, you'd start at -2 and you'd get -3. And then -1 would be -2. And 2 would be -1. 7, you'd get 0. So I'm going to graph those in blue. And for those of you that like doing a little bit of colors, this one isn't a bad one maybe to do some color on. So -2, -3, -1, -2, 2, -1. Now, I want to show this to you as I do this here, the fact that every single one of these points went down 3, or excuse me, to the left 2 and down 3. So if all I did was graph the original and then looked at the transformation, I should be able to go ahead and, if I went left 2 and down 3 from this point, if I went left 2 and down 3, and so on, I would get my new graph. So you don't necessarily have to do the XY chart for the second one because you can just take the transformation and then graph. And so for sometimes it is actually easier to just do what it's asking for the transformation than it is to actually do a separate XY chart. So I wanted to show you that both of those would work. Next one, I got a cubic. So, ready? So cube root, I mean. So 0, 0, 1, 1, -1, -1, 8, 2, -8, -2. So again, just coming up with some points. So 0, 0, 1, 1, 8, 2, -1, and then we got 8, -2. So remember, a cube root kind of makes a zigzag, like a cube root, or a cube, I mean, but it's going sideways. Now, let's talk about the transformation here real fast. It's a horizontal, because it replaced x. It's a horizontal shrink by a half. And on the negative on the outside makes that a reflection on the x-axis. Now, I'm going to do the XY chart because it is kind of, but I'm going to, hopefully you'll understand this. 0 is still 0 in this. Now, if I put in a half, I get -1. If I put in 4, I get -2. Negative a half, +1. -4, +2. And I'm going to, again, use a different color here to try to show this. 0 is still 0. A half, -1. Again, I'm graphing these. So it still makes a zigzag, but it's a zigzag going the other direction. Now, horizontal shrink by a half means everything gets closer to the y-axis by half. Okay, so notice, to get 2, this was at 8. And so now it's halfway, it's closer. The x value, everything has gotten closer to the y-axis by a half. So a half would get you 1. Or 1, 1, then we got a half. But it's also a reflection on the x-axis, so everything got flipped over the x-axis. So it's half closer to the y-axis, and it's been flipped over the x-axis. The function ed equals 0.25 square root of d approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function sd equals 0.44 ed approximates the number of seconds it takes the object to be fallen on Saturn. Write the rule for s. How long will it take? So again, basically they want to do a vertical stretch of 4.4. So 4.4 times 0.25 square root of d. So 0.44 times 0.25 would be 1.1 square root of d. So this is the new function for Saturn. So Earth and Saturn. Now, how long does it take for a dropped object to fall 15 feet on Saturn? So if I'm dropping it from 15 feet, how long will it take? So I'm going to pull out my calculator now. So I'm going to take 1.1 times the square root of 15 and get 4.26 seconds. So think about that. Right? So when you're on Saturn, the gravitational pull is not near what it is on Earth. Okay? When you drop something on Earth, if I were to do this question on Earth, you take the square root of 15 times 0.25, and that would be much, much faster than 4.4 times the Earth. So again, it's multiplying at 4.4 times that long. Let the graph of the horizontal stretch by a factor of 3. This is what this will be on the quiz. Okay, you're going to be given a function and then ask you to do some things with that function. So the original function, and this one's pretty basic, the cube root of x. I want a horizontal stretch by 3. So I'm going to replace x with 1/3 x, followed by a translation 6 units to the right. So again, I'm going to replace x. So I'm going to replace x with x minus 6. Now, because I have a parenthesis inside there, I can go ahead and distribute that. So we're talking about 1/3 x minus 2 is my new function, g, in which I did a horizontal stretch by 3, then a translation 6 units to the right. So we've done this before. We're just now doing it with radicals. Your homework assignment is out of the book. If you have any questions, please make sure that you talk to your teacher. And good luck.